lab is really simple, it's really straightforward, you can finish it in 5 minutes or less. So basically what we're doing in this lab is we're trying to determine the size of the orifice hole that is in the plate between these two, between the section. As you can see, we have here different plates, they have different holes in the middle. So as the water passes, so the water is running through the system, it will go to this part, and since the hole is pretty small, there will be a change in pressure. And using that change in pressure, we're gonna try to determine how big the hole inside is. We're gonna be measuring the flow rate at every time it runs. So we're gonna be doing this experiment 3 times basically. Once when it's all open, then when the bulb is semi-open, and then when it's almost open. And you can see here we'll be measuring how much difference in pressure there is. We're gonna be using 300 inches of water at different pressure, 200 inches of water, and then 100 inches of water. And with those 3 readings, we're gonna try to find the size of the hole. So the size of the hole here is never gonna change. We're just gonna be using 3 different pressures to see how they vary, how accurate the results are gonna be. So you can see everything is connected right here. We have our plate already set up. So we're gonna turn in. What we're gonna be doing is once the water is running, we're gonna come over here. If you see this container, we have a mark here at 1 gallon. So once the water is flowing, and we have our pressure set at the pressure we want, we're gonna close this lever, this valve, and then the water is gonna start rising. Once it stops at the 1 gallon, someone is already timing this, and it will time the time it reaches that mark. We're gonna write that down, and then that will be our flow rate at this pressure. And then we're just gonna raise the water, and we're gonna repeat with a different pressure. So let's do an experiment right now. Let's try the first one. So I'm gonna turn on the pump. You can see water is already coming out. Water is flowing already in the system. You can see right now, only between these 2 points, there's a difference in pressure between about 300 and 20 inches of water. So let's adjust that to something more accurate for our calculations. Just by sliding something in the water. So there you can see we're about 300 inches of pressure of water. We reduce the flow rate a little bit. The difference in pressure between 2 points is about 300 inches of water. And right now someone's already timing me. You can put a timer in there. You will have the time for everything in experiment. I'm gonna close this, and then we'll see how long it takes for it to reach 1 gallon of water. Alright, the reach, someone already pressed stop on the timer. So whatever time it took, let's say it took about 5 seconds to fill a 1 gallon, just convert that to whatever unit you're working with, gallons per meter, gallons per second. And that's already for the 300 pressure. So we continue lowering the pressure. 200 now. Start timer. And we stop. And you can kind of see already that it took a little bit longer, it's a couple of seconds longer to fill up to 1 gallon. And then we reduce now the water to 100 pressure, 100 inches of water. You can even see over there that the water is flowing a little bit slower. And let's time again how long it takes for the water to reach. You can really see the water is flowing even longer. You can see just from these points, just from this experiment, that the less flow rate we're allowing the circuit to pass through, the lower the pressure difference is between the 2 plates. The faster the water is flowing, the more flow rate there is, the higher the difference in pressure we will find out between this plate. So now we turn it off. We have our pressures, we have our flow rates. We're going to use those to work to find out our Reynolds number, to find the K coefficient, the beta coefficient, the C coefficient, everything that we know that we need. And just make sure you use, you convert the pressures and the flow rates to either you're working in the American standard units, per units, or the SI units. Just make sure you have everything consistent. I personally recommend if you convert the pressure to pascals and the flow rate to meters cubic per second, so it can be easier for you to do the Reynolds and so on. And that's it for the Orifice Flowmeter. Everything else will be just doing your calculations. Welcome to the water circle lab. So in this lab, pretty much the same setup we're using for the Orifice Flow. Just this time, instead of using only this part, we're going to use all the rest of the pipes. So you can see we have here different pipes with different diameter and different materials. The first pipe over here, it's a 3/4 inch copper pipe. The next one is a 3/4 inch PVC. Then it's a 1/2 inch PVC, and the last one is a 1/2 inch copper pipe. So those are the names they have, the diameter they're supposed to have. But we already measured the inside diameter, outside diameter, and everything, and we found out that the diameters are not actually that exact. So each one might be a little bit more or a little bit less on its diameter. So you can see we have here different couplings, different sections that we need to measure. We're going to be measuring for each pipe a distance of the pressure 2 feet apart, and then 4 feet apart. So 24 inches and then 48 inches for each of the pipes. And that will be able help us to calculate the head loss. How much pressure loss there is for how much water pressure loss there is from this point to this point, and from this point to this point around the whole circuit. So as I said, these pipes are going to be useful for the major head loss. And you can see over here in this corner, we have also different couplings. We have our elbows, our T couplings, our valves, and expansion and contraction of water. Expansion and contraction. So you can see the water will flow through. There's only one pipe open at a time. And once we have found our major losses, these ones we're going to find the difference in pressure between the quarters, across a valve, across a T couple, across an elbow, and to find out how much water pressure there is. We're losing only on those little quarters. So as I said, these are your major head loss. These are your minor head loss. So let's turn in the pump right now. Let's measure first the pressure at 24 inches, and then we'll continue with the experiment. So when we turn into the pump, there's a little bit of air inside the pipe. So it's good to take out this, just so we can get some of the air bubbles out. And get more accurate readings. You can see we've got about 24 inches in the 3/4 copper pipe. We have about 8 inches of pressure loss. And we are going to find the flow rate at this section. The other flow meter, we're going to close this valve and time how long it takes to fill up one gallon. Stop, breathe water, and now we move the lower pressure side to the next one. We just clean it from the air bubbles. You can see now that 48 inches is about 11 inches of water absorbed. From this point to this point, we have lost 8 inches of pressure. And from this point to this point now, we have lost about 11 inches of pressure. Imagine this in your house, how much pressure you're losing in your house. Your house, you have about 40 to 50 feet of pipe is coming from the sewage to your water in your house, to your shower, to the kitchen sink, etc. So imagine how much water you're losing from whatever it starts, from where the seating is, all the way to the water which is to your sink in your house. It's probably a cool off. Because I think we measure the flow rate. 1 gallon and stuff. And then in order to go to the next pipe, we need to open the other pipe form. Open it. Once open, we close this one.